Admit. Okay, so I am officially recording the uh, screen with Google Classroom that I have not yet shared with you guys, and I am going to share that with you guys now. Share a window, this window, not that one. Wait, yeah, that one. Oh, weird. Let's hope that works. There we go. So, hope you all are doing well. Um, Spring break is over. Quarter three almost over. Our second to last day of Physics 9 stuff. Hey, you made it. What a deal. A few things. Um, Today and tomorrow, the new assignments are going to be very small, are very small point value things. So the emphasis, if I were you, I would definitely emphasize going back and doing other assignments, previous assignments that you might have missed, or previous assignments that you maybe did but you didn't score well on. I would do those sorts of things. Go back, look for stuff that will help improve your grade, uh, help your status in that way. Um, a few days ago, I was working with one of your classmates, excuse me, and they mentioned that they were trying to do a Pivot Interactives lab, but it wasn't letting them change things anymore. And so it appears that, um, and this classmate of yours mentioned that he and I had the conversation first or second quarter. I don't remember which, when we worked together then, that there was an assignment that for some reason after he submitted it, or maybe after I started grading things, it wouldn't let him go in and make changes. So if you are having that same issue with any of the past or present Pivot Interactives assignments, those labs, and it won't let you grade them, or pardon me, it won't let you work on them and type answers in, but it lets you view them, then I can click a couple of buttons and make it so that you can enter them. If it was a couple of buttons and that takes care of everybody, then I would just do that and take care of it for everybody. But it turns out I have to do that for each person on each individual assignment. So I can't just click and then it's done. It would be uh, a mess. So uh, if you have any Pivot Interactives labs that you're not able to work on, that you would have liked to work on or like to do some more work on, and it's not letting you, send me a note. We'll take care of that. So that's the stuff from earlier this week. Um, let's see. Today, I'm planning on things being a little bit of one new thing, which is really a twist on something from Monday, Tuesday, and Friday of last week, I think. So we'll go through the Pivot Interactives lab activity for today on simple magnetic motors. And that's a 3-point assignment. So those of you that are kind of filtering in, the assignment in Pivot Interactives is a 3-pointer, which is fairly small points. We can go through. We'll work on that in like right now in our live time together, and then after that, I'm just going to stay on until 11 to see if you guys have questions. If you've already done the Pivot Interactives assignment, that was given this morning, and you're caught up on things and you don't have any work to do, then you could surely use this time for other classwork, other classes, or whatever you need to do. So today I'm hoping is a day where those of us that need some time on things have some time on things. So I'm going to go to the Pivot Interactives deal and uh, try to get that rolling, and we'll see how she goes. I think, let's see, if I open a new incognito window, are you able to see this incognito window right now, folks, or no? No. All right. So right now you're not seeing it. I will, in a minute, I will present this other tab. I need to see if I can remember. I have to log in as incognito to um, use a generic account that I set up. Um, or actually, you know what? I don't. I can do it. I can do the preview. Haha. So back here, pivot. Blue. Couple more people have filtered in while I'm going through and doing stuff. Log in. So the folks that are filtering in that maybe haven't heard what I've mentioned earlier today, the rest of you get it multiple times. Congratulations. So today, gonna go through the one activity that I'm adding. It's like a 3-point assignment in Pivot Interactives. We'll kind of go through, do that together, um, and we'll see what we can do. That shouldn't take a huge amount of time. And then after that, I'll just basically hang on and see if you have questions. If you um, if you are already done with the assignment that was given today, excuse me, and I need to go there. Preview. If you're already done with this assignment that was posted today, um, and let's see, how can I? Oh, dang. I wish I could I can't just get rid of that. It's kind of annoying. So if you're already done with this activity and you don't have any other work to catch up on, you can hang up and move on and go do what you need to do. Um, so click, there we go. This is pretty cool. This little, it's a little DC motor. So DC is for direct current, meaning we're just using a battery to push things, to push charges through. So it's a battery over here. Yeah, we'll try this again. Mouse. Clicks. So over here, this thingy, just a battery. This thing is really just a temporary switch. You push it down, it connects the stuff, and electricity goes through. Wire, and then this thing here is just a support to hold the wire that carries current. This is a magnet here. This disc is a magnet. Another wire to a support, and then going back to an ammeter, so you can see when the current is flowing, and then back to the battery. The thing that's really cool about this that it would be difficult for us to do at home is that they have a superconductor levitation bit going. So they have a material here, and then they use liquid nitrogen to cool things down, and that helps keep things up and floating. It's uh, really cool. There are other simple motors that we can make at home. This one, you don't have the materials. If you had the materials, it's really as easy as pour the liquid nitrogen in, put that ceramic disc in, put the thing up on top, done. Like, it's crazy how simple that is. And we have positive charges coming through here, positive charges going from here to there, and then up and through. All right, so we'll try this. Let's see, I'll try going full screen so that gets some of the other stuff out of the way. And this now lets me move this. There we go. So they connect this switch, and now current goes from here to here, and this magnet, this permanent magnet, just starts spinning because, and this is all the thing that makes this so cool, or the thing that I think is really so cool about this. This is that stuff that we were talking about with our right hand. It's all right hand rule stuff that makes this happen, and it's just a really crazy simple, right? I mean, it's a wire, a magnet, there you go. Well, and a battery, and there you go. When this stuff was first discovered by Faraday, I believe it was, when he first discovered this, it was basically he connected a switch, and that made a compass needle someplace else kind of twitter, right? It not like, well, you know what I mean. It just made this compass needle a little ways away move, and he presented it to the public, and the public was like, "Ooh, that's awesome!" But there were a lot of people that were like, "That's awesome, but of what use is it? You know, making a little compass needle move some distance away. And that's a reasonable first thought, right? Like, what's the use of, it's neat, but of what use is it? Uh, and legend has it that he said something that's pretty shocking. But the gist of it is uh, most new discoveries, we don't know their full potential until decades beyond that discovery. At the time, there were people wondering, so what? You move this little compass needle. But this is the foundation. What he discovered is the foundation for like 98% of the electrical energy generated in the world. The only electrical energy method that doesn't use this is solar. Well, and I guess fuel cells. But nuclear power plants use this. They boil water, makes charges move in a magnetic field, and there you go. So nuclear power, coal, any fossil fuel power stuff that's used to generate things, wind generators that spin, all of them have something that spins in the presence of a magnetic field. There you go. I'm babbling now. I find that stuff really interesting. The weird phrase that he used, the woman said, "Of what use is this?" And the somewhat inflammatory phrase that he said, "Of what use is it? Of what use is a newborn child?" It's like, good God, man, it's pretty harsh. But the intention being, hey, right now it eats, poops, and cries, maybe giggles. Eventually, it'll lift his head. In the future, its possibilities are limitless, right? It's a baby. Right now, it's a baby. We love it, we care for it, but of what use? But the possibilities are endless. So that's the way I like to think about research in science. The possibilities are endless. We don't know what their use will be. So this is just trying to kind of show the supports that we've got, where we have this wire going in, that wire going up. And so if this side is connected, so if this bottom side is connected to the positive side of the battery, then we have positive charges going in, and then the positive charges go up this wire here. So you have positive charges going that way. Yeah. Um, and then this is, we're going to now start trying to go through and use our right hand rule. So remember, use your right hand, not your left. So take your right hand out. This is like TV when they say, "Do you swear to tell the truth, the whole truth, and nothing?" Well, not quite that, but you need your right hand out. Got to be your right hand. And then we're going to point our thumb in the direction of conventional current, or if we imagine positive charges to be moving, which way are they moving? So positive charges are going from this spot to that spot. So if we imagine this roll of tape to be the disc, that magnet, we have charges going from here into here. So I would take my right hand and I would take my thumb and point it that way, which would be, if this is the screen, there's a disc, I'd be pointing my thumb into the screen in the direction of positive current flow. Kind of okay? All right. So now thumb is going in, but now the rest of my hand can pivot in a bunch of different ways, right? It's easier to stand up because you, right? The thumb can stay pointing that way. Thumb can stay pointing that way, but my fingers can rotate into a bunch of different directions. And the palm, the direction that your palm is facing, is the direction of the force. So right now, all we know is thumb into the screen. So thumb into screen. Submit. Woo! Then if we said that if the magnetic field pointed to the bottom, so this magnet, it could be magnetic north is pointing up, the field is up. It could be magnetic north is pointing down to the bottom of the screen, magnetic field is down. So we're going to test it out and see what we would get. So if the magnetic field is going down to the bottom of the screen, I would still have my thumb pointing into the screen, like this is the screen, thumb pointing into the screen. And if the magnetic field is pointing to the bottom of the screen, then I need to thumb into the screen. I need to point my fingers to the bottom of the screen. Yeah? Okay. So thumb in the direction of conventional current into the screen. and fingers in the direction of the magnetic field, which we don't know the direction right now of the magnetic field on that magnet. But if magnetic field was going down, then our fingers would go down and the push would be to the left. Yeah. My palm is here. My palm is facing to the left. It would be pushing things to the left. Make a little bit of sense? Okay. So thumb in, because that's the direction of conventional current. Thumb in, fingers down, because that is a way to test the magnetic field. If the magnetic field were down, then the front end of the magnet would be pulled or pushed to the left. So I'm going to go for the above, which direction would my palm face? It would face to the left. Submit. Ooh, oh, is that saying it's not right? Ta-ta, ta-ta. Oh, that's supposed to be right. I need to check and see what I did there. And now we say if the magnetic field is pointing to the top of the screen, thumb in, and our fingers would go up, and then the palm would go to the right. Yeah. Thumb in because conventional current would be in, fingers up because the magnetic field is up, or we're testing to see if it's up, and then it would be pushed to the right. Is that okay? Oh, did I say, what did I say over here? I said, no, that's to the left. All right. So, so then here we would say my palm faces and the force is to the right. I don't know if that will take it. Woo-hee! There we go. And so now we can go back and we can figure out the direction of the magnetic field, right? So if we go back up here and we watch it, right? So the front is going to the left. The front is going, from my view, it's the front is going that way. So the force is that way. So I'd have fingers. What the heck is that? I need to do this. Fingers in. Yeah, yeah. So for me, if this is the screen, fingers in, magnetic field up, and then the force is this way. Yeah. So the magnetic field must be up. This is not a question that's asked in the video or in the lab, but that's the direction that the magnetic field must be. The magnetic field must be up to push the top front edge of this surface this way. Hopefully that makes a little bit of sense. So now with this setup, when we connect this and we have all this stuff going, we're putting electrical energy in and we get this mechanical energy out. The magnet spins. The weird thing, or the kind of cool thing, is that if we disconnected the battery and instead we put in a really efficient LED, a really efficient light, yeah, what we could do instead of putting electrical energy in and getting kinetic energy from this, we could flip things. We could, with all of these things connected, but swapping out the battery with like a little LED, we could put mechanical energy in and we could grab this little magnet and we could just spin that bugger as fast as we could. And if we do that, well, we would have charges moving here in a magnetic field, and there would be a force on those charges because of the magnetic field. And we would then be producing a voltage and we would produce electricity. So the crazy thing is that if we do it in reverse and we spin the magnet, it makes a voltage and it makes current, and we could light the freaking bulb over there, right? So it works forwards and backwards. We can put a battery in, close the switch, and this thing spins. Or we can take the battery out, put a little LED in there, and spin the magnet, and we get electricity. It works forwards or backwards. It is so freaking cool, right? And so that's how all of the electrical energy in the US is made, with the exception of solar panels and fuel cells. wind generators, water turbines, coal power plants, nuclear power plants, all of those things. And the regenerative brakes on your car, as somebody just asked, can you use it to charge a battery? Yeah. And that's how the regenerative brakes on electric cars, that's how those work too. There's like a magnet here. You spin that bugger, it produces electricity, and you can either light up a bulb or you could charge your batteries, right? That's how all of those things work, which is just phenomenal, right? I mean, and if you then work that same thing in reverse, well, you get mechanical energy. If you use mechanical energy to spin the magnet, you get electrical energy. So awesome, right? Solar cells and fuel cells are very different. You've surely heard of solar cells or solar panels. Fuel cells you haven't probably heard of, well, you may have heard of them, but they're a very different thing, and they're a complex thing. But they're also really cool. All right. So those are the three questions. I'll have to change. It looks like I'll have to change what's accepted as an answer for that second one. My apologies for that. Um, and then these DC motors, they're DC direct current because the battery produces the energy for these things. There's a bunch of different simple magnets that you can make if you check the YouTube. Um, there's a bunch of simple little magnets that you can make that are pretty, oops, pretty easy to make. You just need to have the stuff. If you have a battery and a good magnet, the little magnet that he's showing there, neodymium, a good battery, a good magnet, and a wire, you can make some pretty cool things. If we were in the before days, we would make these. We'd take a day and we'd make these. It's pretty awesome. If you're in the building next quarter, so am I, and I'll try to set some stuff up. So if you have a moment, just a moment, you could maybe stop in and putz with some of that stuff. But all of those motors work. Those are pretty cool. Um, don't see the answers to one and two. Give me 1 second, man. I'll be right back. Uh, and this one is, I didn't believe this one at first. The first time I saw this, I thought for sure it was one of these prank things, like, ooh, look at this, I made a car out of potatoes. I thought it was some crap deal, but it works. And it's insane. So we'll put that on high speed so we can see stuff. Um, right, same principle. So in a second I'll go back and we'll take a look at the questions to make sure we all have those answers, and then I'll stop talking and we can check questions. And my apologies, started babbling quite a bit more than I had intended to, so I've taken up most of our time talking about this stuff is just really awesome, right? So I get carried away sometimes. All right, so I'm going to escape that one, and we come back here. So the questions that we're looking at, the first one, it's your thumb goes in the direction of conventional current, or your thumb points in the direction that we would imagine positive charges would go. So if we're saying positive charges go from this wire into this wire that's supporting things in the center, I take my right hand and my right thumb points into the screen. So I'm using this as my TV screen or my monitor, and I'm imagining the magnet to be here. That silver disc is a magnet. And so my thumb would be pointing into the screen. That's the direction positive charges would go. So for this one, it should be your thumb should point into the screen. First question. Somebody asked in the chat that they said that they didn't see all of those directions. So I'm going to go back and just make sure that we have them all. And this one, I need to change. It seems I need to change the key because it says 3 out of 4 submissions left. So it's reading this is wrong. But if the magnetic field points to the bottom of the screen, well, I would still have my thumb pointing in. And if the magnetic field points to the bottom, then my fingers need to point to the bottom. So I need to get up and say thumb to the screen, fingers to the bottom. And then if my fingers are pointing to the bottom of the screen, thumb into the screen, my palm is facing left. So I should have a force to the left. And so this one says my right hand should be, the palm should be facing left. The force is left. That should be the answer to number 2. I have to change that on the key, it seems. I must have either not entered an answer or entered the wrong answer. Um, and then if the magnetic field were pointing up, if the magnetic field points to the top of the screen, then your fingers, not thumb, should point to the top of the screen. My thumb would still be pointing into the screen because that little metal magnetic disc there, thumb into the screen. And if the magnetic north is pointing up, my fingers go up. And then that should be pointing, my palm is facing right. So the push on those charges and that thing containing the charges would be to the right. My palm faces and the force is to the right. Those should do it. I'm going to try to go and change the key on this right now so you're not all buggered up. That's what I got for you. That took much more of the time that I had intended. My apologies for babbling so much there. I think we got her done. Oh, that's not what I was trying to do. There we go. All right. So, any questions on anything? So I'm going to just hang out. And if you are ready to hang up, you can hang up. If you have questions, ask your questions. There you go. Thank you, man. Thank you to the folks in the chat.